Good evening, y'all. My name is Keelan Wright, and today we'll be talking about factoring polynomial expressions. For the purpose of this video, I'm only going to be talking about polynomial expressions with a degree of 2 and 3. So there's a couple of different methods I'll be going over in this video. So the first method is the sum product process, the second, the quadratic formula, the third, completing the square, and the fourth will use the fundamental theorem of algebra. To my knowledge, I do not know of the actual name of the technique, but I will show you what it's based off of. And in this video, we'll be doing 4 examples, and these are the 4 examples. Each example will correspond with one of the methods that I've just talked about. So 1 will use the sum product process, 2 will use the quadratic formula, 3 will use completing the square, and 4 will use the fundamental theorem of algebra. So, for the first one, we're given f of x is equal to x squared plus 10x plus 24. So, when you're trying to solve these, what you initially want to think of is a times b. A and b are both numbers. A times b will be equal to 24, and a plus b will be equal to 10. So that is to say that what multiple of two numbers will give you 24 and what addition of those numbers will give you 10. So you're trying to find two numbers that when multiplied together will give you the last term and when added together will give you the middle term. So off the top of my head, I can think of a couple, 6 and 4 and 8 and 3. Both work with the first set of equations, but they don't add 8 plus 3 is not 10. 8 plus 3 is 11. So the one that will work in this one is actually 6 and 4. So we'd have two sets of parentheses. So we will have x plus 6 and x plus 4. When you actually multiply this back out, you do get the original equation, and I will show that. X times x is x squared. 6 times x is 6x. 6 times 4 is 24. 6 times x is also 6x. X times x is x squared. X times 4 is 4x. 6 times x is 6x, and 6 times 4 is 24. Six x plus 4x is equal to 10x. So x squared plus 10x plus 24. So this gives you the original equation. So algebraically, this part checks out. So that's actually the factoring process, but in this one we're solving for x. So when you solve for x, f of x is equal to 0. The only way you can factor expressions and equations, you have to have all the variables on one side and there has to be 0 on the other end of the equal sign. So you actually have 0 is equal to x squared, 0 is equal to x plus 6 times x plus 4. When you have your factored expressions on one side and you have 0 on the other end of the equal sign, you can actually set them both equal to 0 independently. So we can say that x plus 6 is equal to 0. And we can say that x plus 4 is equal to 0. Subtract 6 on both sides, x is equal to negative 6. Subtract 4 on both sides, x is equal to negative 4. These are your solutions for the given function. Now, if these are the solutions, when I plug them back in, f of negative 6 should give me 0, and f of negative 4 should give me 0. So we can check those answers. So first I'll check f of negative 6. F of negative 6 is just saying f of x when x is equal to negative 6. So what we want to do is we want to rewrite the original function. F of x is equal to x squared plus 10x plus 24. And everywhere that we see an x, we will substitute in a negative 6. So that's f of x, f of negative 6. You want to keep these parentheses around it, be equal to negative 6 squared plus 10 times negative 6 plus 24. So when you have this, you just want to simplify it back down to see if you actually get 0. So negative 6 squared is 36 plus 24 minus 60. So we will have 36 plus 24 is 60. So you actually end up with 60 minus 60, which is equal to 0. So because f of negative 6 is equal to 0, x can be equal to negative 6. The second one we want to check is f is equal to negative 4. So again, f of x is equal to x squared plus 10x plus 24, which means f of negative 4 will be equal to negative 4 squared plus 10 times negative 4 plus 24. This will be equal to 16 plus 24 minus 40. This is equal to 40 minus 40, which is equal to 0. So the proof is because f of negative 4 is equal to 0, x equals negative 4 is a valid solution. It's a valid solution of the equation, but I'm running out of space. So that also means that x equals negative 4 is also valid. So for the second question, we're going to use a different method. So we used the sum product process on the first question. The second method, actually before I show you that, the second question is going to use the quadratic formula. Before we can do the quadratic formula, we need to actually know what the quadratic formula is. And this is the quadratic formula. See if I can get it to focus. 1 second. There we go. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac over 2a. So for question number 2, we're going to try to find the variables for a, b, and c. So a will be whatever constant is in front of the x squared variable. Because nothing's in front of the x squared variable, a is assumed to be 1. B is the constant in front of the x variable, and that is 11. And C is just a constant, it's 27. So what we want to do now is we want to write the quadratic formula and plug in all the numbers. So we know the quadratic formula is negative b plus or minus the square root of b squared minus 4ac over 2a. So plugging in our numbers, we'll have negative 11 plus or minus the square root of negative 11 squared minus 4 times 1 times 27. All of that over 2 times 1. So what we want to do now is we want to simplify everything underneath the square root, and then we just want to see if we can reduce it down to a more simple form. So we'll have negative 11 plus or minus the square root of 121 minus 4 times 1 times 27. So Let's do some offhand math right here. See what 27 times 4 is. So 27 times 4 is 108, all over 2. So our answer would be x is equal to negative 11 plus or minus the square root of 13 over 2. For the sake of this video not being too long, I'm not going to check it in this video. If you do want me to check it later, just let me know in the comments and I'll go back to it. So that is quadratic formula. For our next question, we're going to try to solve it using completing the square. So our next question is f of x is equal to 3x squared plus 5x plus 13. So something that's important for completing the square, you can't complete the square until the constant in front of the x squared variable is 1, which means that we have to divide everything by 3. So f of x is equal to 3 times x squared plus 5 over 3x plus 13 over 3. If you were to multiply the 3 back out, you get the original equation. So we're still doing mathematically accurate stuff. Next, whenever you're completing the square, you're actually trying to make a perfect square with these first two terms. And the way you do that is you take this term, this number, the 5/3, and you divide it by 2. And then it would be x plus or minus, depending on this sign. It would be plus. Ours is plus, or ours would be plus in this example. It would be x plus this number over 2 squared minus this number squared plus 13 over 3. And that's because we actually need to balance out the equation. So f of x will be equal to 3 times x plus 5 over 6 squared minus 5 over 6 squared plus 13 over 3. So if you look at this, when we actually FOIL this back out, we have x squared plus 5 over 3x plus and then 5 over 6 squared. But 5 over 6 squared isn't actually a part of this original equation. So what you have to do is you have to subtract off 5 minus 6 squared, and then it's balanced again. So we can simplify this down. It's a little tedious, but it's doable. So f of x will be equal to 3. And then x plus 5 over 6 squared minus, and then we have here 25 over 36 plus 13 over 3. So we need a common denominator before we can actually simplify off this expression right here. So I'm just going to use 36. So I don't want to do any weird math. So I'm just going to multiply this 13 over 3 by 36, or excuse me, by 12, because 3 times 12 is 36. So first, let's find 13 times 12. And we already know 3 times 12 is 36. So f of x will be equal to 3 x plus 5 over 6 squared minus 25 plus 156 over 36. Do some more side-hand math to get 156 minus 25. So f of x is equal to 3, and then x plus 5 over 6 squared plus 131 over 36. And then finally, for factoring this down, we just distribute out the 3. So f of x is equal to 3. I can drop the braces now. X plus 5 over 6 squared plus 131. It's 131 over 36 times 3. But also, we can just break it down. Well, 36 divided by 3 is 12. So it's 131 over 12. You don't have to write it like this. You can leave it as 131 over 36 and then times 3 if you want to. But you also know that this is also algebra right here. This cancels off. Because you just think of what it has in common. And what it has in common is a 3. So you take a 3 out of this, you get 1. You take a 3 out of this, you get 12. So that's where that comes from. So this is actually the final step of factoring. One of the beauties of completing the square is you actually get the equation of a parabola. Because if you think about it, a parabola, just using any variables, it's basically y is equal to some variable out front. This is just a constant a. Then x minus, just say x minus k. Plus or minus for this, plus or minus k. For example, it's positive, so we'll just use positive. X plus k squared, and then plus b. And then a is a vertical stretch or compression, it depends. And then this b at the very bottom is a vertical shift, and then you can actually use k and b to get the vertex. It's negative kb. So now let's try to solve for x. So we're going to take this equation. Actually, we're going to take this one because it's a little bit simpler. We're going to solve for x. So when you're solving for x, we know that f of x is equal to 0. And we also know that f of x is equal to 3 times x plus 5 over 6 squared plus 131 over 36. So we can say 0 is equal to 3 times x plus 5 over 6 squared plus 131 over 36. Divide out the 3. 0 over 3 is 0. So 0 is equal to x plus 5 over 6 squared plus 131 over 36. Subtract over the 131 over 36. Negative 131 over 36 is equal to x plus 5 over 6 squared. Take the square root. Square root plus or minus negative 131 over 36 is equal to x plus 5 over 6. And we've actually run into a problem here. So the problem is we can't take the square root of a negative number. So because we can't take the square root of a negative number, this value, it's actually no solution. You can't determine that. So because of that, x, you're going to say no solution here. And if you remember what I talked about earlier with the graph, if we look at the equation that we have, and we were to sketch a graph out of this, we can sketch a graph out of it. So, a quick rough sketch Our original equation, our equation for the graph is f of x equal to 3 times x plus 5 over 6 squared plus 131 over 12. This doesn't matter for a rough sketch. This is just a vertical, this is actually a vertical compression, but for the sake of this, it's not too relevant because it's a rough sketch. So we know the vertex of this will be negative kb, because this is in the actual form of a parabola. This is the equation for a parabola. So the vertex would actually be negative 5/6, and then positive, and then it's 131 over 12. So here's your vertex. We're not going to use this 3 because it just makes it more narrow, but this number is positive, and that's important because it means this will open up. So it actually opens up like that. And if you look at this graph, you start to understand, you can see why we didn't have a solution for x. This graph actually never touches the x-axis, which means that we can't have an x-intercept. So that's also a nice way you can see it by completing the square. So that is the third question. The final question is a third degree polynomial. So our final question is f of x is equal to x cubed plus 27. Now, you remember I mentioned the fundamental theorem of algebra earlier. So the fundamental theorem of algebra is just a really fancy way of saying if I have x cubed, I can represent x cubed as saying it is x to the first times x to the second. If I were to work this back out, x times x squared, the bases are the same, which means it's be equal to x raised to, and because it's being multiplied, I add the exponents, raised to the 1 plus 2. 1 plus 2 is 3. So x times x squared is equal to x cubed. So what we want to try to do here is we're actually going to take this concept and we're going to try to take this expression and break it into something in parentheses that has a degree of 1 times something else in parentheses that has a degree of 2. So then, when we actually go back to double check it and see if it's right, we actually get something for degree of 3, and that will be our original question. So what we're going to try to do for this question is, in order to solve these, you need to take the cubed root of each term individually. So that means that for the first set of parentheses, you're thinking the cubed root of what? The cubed root of x cubed is what? So what raised to the power of 3 will give me x cubed? Well, we know x times x is x squared times x is x cubed. So the cubed root of x cubed is x. We're going to use that same train of logic for 27. So you want to think of what raised to the power of 3 is 27. Well, it's a bit more than 2, but 3 times 3 is 9 times 3 is 27. So the cube root of 27 is 3. That's the first set of parentheses. For the second set of parentheses, what you want to do is you want to square the first term, so x squared. You want to multiply the next two together, so you want to multiply x and 3, so x times 3 is 3x, but then you want to switch the sign, so it's not positive 3x, it's negative 3x. And then for the last term, you want to square the last term in the first set of parentheses. So that is positive 9. So this is actually the factored form of our original question. This has a degree of 1 because this is x to the first. This has a degree of 2 because the highest one is x squared. So what you want to do, we can actually check to make sure we get the original question. So I'm going to multiply this all out. X times x squared is x cubed. X times negative 3x is negative 3x squared. X times positive 9 is positive 9x. 3 times x squared is positive 3x squared. 3 times negative 3x is negative 9x. And 3 times positive 9 is positive 27. We can look at our similar terms. So these cancel, and we're left with x cubed plus 27, which is our original question, which means that this factor we determined is valid. So in this video, we went over some of the more basic forms of factoring. So we use the sum product process that states the last term. So if I'm given an expression x squared plus bx plus c, we need to find two numbers that multiply to give me c. So a times b will equal c, and a plus b, should probably use different variables. We're looking for two numbers that will give me c. We'll call it a and d. So a times d will give me c, and then a plus d will give me b. That's a sum product process. The quadratic formula, you just memorize this formula, and you just plug in the numbers. And completing the square is you actually take the original expression x squared plus bx plus c, and you divide b by 2, and then you basically square that. So it'd be x plus b over 2 squared minus b over 2 squared plus c. And this part right here is actually the perfect square. The fundamental theorem of algebra is just a manipulation of x times x squared to actually break the original question down into components with a degree of 1 and 2 to solve for it. These were the questions we did. And on question 1, this is how we went about solving it. So for the sake of not wanting things to be too confusing, we're going to call this variable d because we use b on quadratic formula. So this is variable d. A times d is equal to the last term. A plus d is equal to the middle term. And that's what we got. Then we went and we checked it. And both of them were equal to 0. On the second question, we found the values for a, b, and c. And then we plugged it into the quadratic formula, and we just simplified the formula down until we got to an answer. On the third question, we took the original question, and we took a 3 out of each term, so I'd have a 1 in front of the x squared variable, so I can complete the square. 5 over 3 is my b. I divided that by 2 to get the perfect square part of x plus 5 over 6 squared. This right here is your perfect square. But because the positive 5 over 6 squared wasn't there before, we have to subtract it off, which is what you see here. This balances the equation. And then we just simplify that down to get this expression, which is actually the equation of a parabola. Then we try to solve for x, but we determined we actually can't solve for x because you can't have the square root of a negative number. And then we also sketched the graph to see that the actual function never crosses the x-axis, so you can't have an x-intercept. And on the last question, we went and we took the principle of x times x squared is equal to x cubed to break this equation down into two sets of parentheses, one for degree of 1, one for degree of 2, to get the factor, and then we check the factor by multiplying it back out to get the original equation. So that's it for this video. If you guys have any questions or comments, please let me know. But I hope you guys learned a little bit about factoring, and I hope you guys have a nice day.